Hello, everyone. The second session this week to talk about lecture number 3, which is about the equals method. We already went over a list of questions yesterday on the Google Doc, and I will show you the link that you can refer to if you are interested for section B, but you're definitely welcome to watch. And I think I got one more question from the Google Doc from this morning, and that one is rather straightforward, but I'll go over them anyway. But at the end, if you got any follow-up to any of the lecture material, let me know. Okay. Let's now get started. Okay, some quick announcement for you. Just let's go over them. Just to make sure you don't miss any important items for the course. Lecture week number 6. So this is about aggregation and composition. Okay, aggregation and composition. And this topic will be covered in your lab number 3 and also your coming written test 2. So please make sure you don't fall behind of studying the lecture. And for this lecture here, we'll discuss about the any questions you might have next Wednesday and Thursday. So you definitely got a chance to actually clarify any doubts before the actual written test happened. I'll talk about your written test number 2 in just a moment because I just released the guide. I can go over some policy together with you. Okay. And also, specifically, the topic about copy constructor is what you have to, what you will need for your lab number 3. You will see that. Okay, so just make sure you actually study that in time. And then for your lab number 3, I also released that. It was back on Tuesday. Okay, so you should really get started. And notice that the deadline right now, I kind of took one of your suggestions from the midterms course survey. So because you got your written test number 2 due on like a 2 p.m. on a Friday. So I just moved the due dates for lab number 3 to be over the weekend. So you will be on Monday, 2 p.m. Eastern time instead. So please check your lab manual to for the precise deadline for your lab. Okay. And for your written test number 2, which I want to speak briefly about. So it will be due not this week, but next week, this time, 2 p.m. Right. So the policy and everything, the only difference this time will be some extended time for you. I'll spell it out precisely, and also the format will be the same, but the coverage will be a little bit different. Okay, let's now go over that quickly. So where can you find about your written test 2? I just sent out an announcement from eClass. If you haven't got a chance to check your email, that's okay. You should have gotten that already. So go to the lecture site and go under week number 5, okay? And then you will see that the guide for written test number 2, right? That's a PDF you can look at. If you simply, if you go directly to the eClass announcement, I also included the link over there for you to click on. Either way, if you click on that, okay, so mostly the same policy as before, but I would encourage you to really read it over. Just make sure you don't miss anything, okay? And this time, I extended the time to be 30 minutes, and also I'll try to review the level of difficulty for the test to make sure everybody got, well, the average student will get enough time to complete the test. We'll see how that goes, okay? But this time you got extended time, not 20, but 30 minutes. And other policy is pretty much the similar. It will be open for submission 2 p.m. on Thursday, and it will be closed for submission 2 p.m. on Friday, the same as last time, right? And the type of question that you will be given will be also similar to last time. So I'm just reiterating the policy about how we actually calculate the marks. For example, for the question where multiple answers might be expected for the correct answers. You can read them over. What about the coverage? You do not need to study the labs that we actually have you do. You know, the lab number 1, 2, and 3. You don't need to. Okay, but of course you should still actually complete your lab number 3 at the same time. You're not supposed to only start your lab number 3 maybe after your written test 2 is actually due. It might be too late. So that's my advice for you. Okay, so what about the topics to be covered? It will be lecture 2B about test-driven developments with J units, and also equals method in lecture number 3. And also lecture number 4, which I just released on Monday, aggregation and composition, and also call by value. That's the first topic I spoke about. Just for your convenience, I included a link for the slides, the PDF over here. But if you want to, you may either have to catch up with your lectures if you haven't done so, or you may have to maybe rewatch some certain parts of the video if you got any doubts. But my office hours are as usual. You can always drop by and chat with me if you got any questions. And for the example question, I'll definitely make some example question to you. But this time, I want to design the test and also make the practice question available at the same time. So that's why it might take a little bit, take me a little bit more time to release them for you. But I would say by the end of Tuesday, October 26th, which is about 2 days before your actual test. So you definitely get time once I release them to try them out and then to see if there's any further question you want to ask. So for example, if I make it available sometime on Tuesday, you can still try that on Tuesday or Wednesday. You can still ask me questions during the Q&A. So you definitely got opportunity to clarify any doubts. All right. Okay, just to let you know, so we don't have any practice question right now, but it will be available by Tuesday. Okay, and before that, you should really study all the materials as listed in section 4 about these 3 lectures. If you haven't, you really want to catch up. Okay. Do you guys have any questions related to written test number 2? Any questions? I can take them right now. Anyone? You can speak up or you can put on the chat, either way, about written test 2. Okay, looks like none. All right, that's good. Another thing I want to draw to your attention. So you can see under week number 5, so this is the recording from yesterday. Okay, so that's from yesterday, October 20th, like a Wednesday. I would encourage you to actually go to the recording. Okay, go there. And then you will see under the video description over there, I got some roadmap for the section, right? Yesterday, we discussed quite a bit of details about understanding the equals method. Specifically, I think for this part over here, understanding how the getClass method will actually return the dynamic type for the context objects. I think that's something already addressed in the lecture itself. But I think for the lecture, since I got some time constraints, so I didn't address them in complete details. I think if you watch just this particular part, I also make some source code available to you. So you may want to just at least watch this part just to get more understanding. I think that will definitely help your written test number 2 and exam later as well. We got other topics as well, so you can definitely look at that, right? That's something I may not repeat, but if you got any other doubts, once you watch them, you can also reach out to me, okay? I also got some source code from yesterday. You can just download it, import it to your Eclipse, and play with it about how to invoke the getClass methods. Okay, so that's about what I want to refer to you about the questions from yesterday. And for now, let's now go over to the Google Doc question. There's only one new question, but let's now go over them. You might learn something anyway. Okay, it's quite a straightforward question here. Instead of using the 3 different if statements, can we simply use one if statement and else if for the rest? The answer is yes. Okay, let me just be a little bit more precise about what I meant by yes. Okay, so it's actually yes to your fellow students. Okay, the reason that I'm pretty, if you attended my previous Q&A questions, Q&A sessions, you must have heard I actually said that it's not really recommended for you to have multiple returns in your method. So you might be wondering, why are you showing us the version with multiple returns over here? The reason is this is simply just the standard way that Java API, a Java object class recommends you actually use. You actually override the equals method. I just want to follow the standard. However, if you like, you can definitely rewrite it in a way that will be equivalent, but you follow the single return principle, which I can show you right now about how to write it. That's not something I mentioned in the lecture. Okay, I just wanted to teach you the standard in the lecture, but if you're wondering about any other alternative that might be a better practice, we can definitely see that. Okay. So now here you can see the reason that we can simply got 3 if statement over here, well, it's really just testing about your knowledge about if statements from the first year. Let me mention very briefly, right? You can see this if statement here, if it is actually, this branch is evaluated true, that means you're going to simply return true. And then the whole method will simply terminate and then return true. Okay, so that's why you don't really need else if in this case, because you're returning from there anyway. So there's no need to actually go to another branch. Okay, but we can definitely actually write it in a slightly different way. Let me show you how I will write it ideally, just for hopefully the more clarity consideration. How I would do it is I want to do the single return, let's say single return version. single return version. Okay. However, to save a little bit writing, let me say the following. Okay, let me just say this. Can we just say this Boolean condition here is simply, I call it 1. Okay. And for this Boolean condition over here, I call it 2. And for this Boolean condition here, I call it 3. Okay, 1, 2, and 3. And I'm going to take the suggestion by your fellow student. Can we simply use else if statements? Okay, that's what I'm going to do. Okay, but I'm going to have only a single return at the end. Let's see how we might do that. So I would say this. I would say if 1 is actually true, in that case, I'm going to, oh, you know what? Before that, of course, I need to introduce some Boolean variable. Let me just do that. Okay, let me just put it here. So let's declare some Boolean variable, some Boolean, let's say result, or I can say equal if I let's say equal. Okay, so let's say it's simply initialized to, we don't need to initialize it. We're just going to reassign that to some value, but default value should be false, of course. Let me say equal like that. Okay, eventually I'm going to return just the value for equal, so only a single return. That's what I will do. So let's say if 1 evaluates to true, in that case, I can say equal over here is assigned to false. Right? This one is obvious, right? Because rather than returning rather than returning true, I think I really meant to say true over here. Beg your pardon. So rather than saying returning true, I'm just saying equal is assigned to true. I'm returning that anyway, eventually. Okay, what about the second one? For the second one, so now we are not going to return prematurely anymore. So we just need else if over here. Okay, so we might say else if, and then let's put condition number 2 over here. And if you recall in my lecture, right, there is a way to really collapse 2 and 3 together, which we can do 2 or 3. Right? If you wonder about why, you can definitely refer to the lecture. So I'll let you study that if you got any question about why we can collapse them, and also the consideration about how the short circuit effects of the logical operators will be evaluated at runtime. If you got any doubts, you can let me know. But for now, I'm going to write it, just assuming that you understood why they will work. And in this case, I'm going to say equal is going to be false. Okay, and then so we have so far we have covered these 3 already, and we have to cover the final part, which is about knowing that the obj, the parameter is not null, and also the context objects and obj are dynamically of the same type. So that means we can cast obj. So if you're wondering about the cast, you can also refer to yesterday's recording. I also spoke about typecasting to clarify for your other fellow students. Okay, so now we can say otherwise like else. Okay. So now reaching this line, we know that this and this and obj, the parameter, dynamically they are of the same type. So that's what we can do, similar to before. So we can say point. So we'll talk about point v2, and then we'll say other is assigned to point v2 obj. And we don't say return just yet, but we're going to say equal is assigned to, so we'll say this dot x equals other dot x. And just to remind you, here we can say other dot x because of the typecasting that we have done. And we're going to talk more about typecasting starting from next week when we actually get to the inheritance topic. But you should definitely know that if I simply try, for example, obj, the parameter whose static type is actually objects. If I try obj.x or obj.y, and we explained that in the lecture, these two will simply not compile. Okay, so that's why we have to bother with the cast. It's simply unavoidable. Okay, and also we got this dot y equals other dot y. Okay, finally we can say, okay, after this else, right? You can see we got different ways to really different way to initialize the equal Boolean variable. Either initialize that to be true, or initialize that to be false, or initialize that to be this particular Boolean expression. If, else, right? 3 possibility. Finally, we can say return. At the end of the method, we can say return equal. So we only have a single return. To me, this seems to be clearer in terms of defining your method. You only got one single return. You don't have to worry about when the multiple points where your method might just terminate prematurely. Okay, so this is a single return. All right. Okay, do we have any questions about this question here? Oh, any follow-up to this question here? Any doubts about my explanation here?
Hello?
Yes.
So if object is equal to null, then doing object.getClass will throw a null pointer exception, right?
Nope. So very briefly, but I think you maybe missed that particular part of the lecture. So the question was, what if obj over here is actually null? That's what you're asking, right? Let me point it out quickly. Yeah. It's a good question, but it's already covering the lecture. I can mention that briefly, but I will also rely on you to revisit that lecture. What if obj is null? Okay, let me talk about both cases. Okay, that's a question. Let's say in this case, you can see these conditions over here. If you so let me just highlight. If you look at this part over here, version number 1. Okay, if you look at that, in this version over here, if obj is actually null, that means you would have evaluated this expression to be true, meaning that you would have returned false already. You never get a chance to evaluate this expression over here. That's for version number 1. Okay, that one, hopefully you're okay. What about version number 2? For version number 2 over here, that's what I discussed in the lecture. So number 2 is about obj equals null, right? If object is actually null, that means for number 2, it's going to be true. And according to the short circuit evaluation, if for disjunction, the left operand is already true, do we actually bother to evaluate the right-hand side and let it have a null pointer exception in this case? Right? The answer should be no. Do you follow so far?
Yeah.
So I would suggest you may want to review that particular lecture. Okay, this is where you should really look at. Go back to week number 5. Okay, and then you may actually want to review this part over here. It seems to me maybe you've forgotten about some details about the short circuit effect. Look at this part over here, part F, where I actually review about what short circuit effect is, and then you want to review that G1. So this, I believe G1 or G2, I forgot. Maybe G1. That's the exercise that you just referred to about if obj is actually equal to null, are we going to get null pointer exception? Sounds good to you?
But I have a follow-up question though. Could you go back to the slide?
Are you okay with the? Do you see my point about the short circuit effects over here?
Yeah.
Okay.
So what if, like, in the or statement, 3 comes first and 2 comes first, so there's no like short circuit?
That's exactly why I want you to look at a lecture. I discussed both of them.
So then if the object is null, and like theoretically we do call.
No, answer my question first, please. Have you followed through those lectures yet?
Yeah, I did watch them. I just don't think I remember.
Yeah, so that's why I think for the detailed explanation, you may actually want to look at these 3 again, because those are in there actually. I can explain in detail about the 2 possibilities you just mentioned. Okay, have you followed me so far?
Yep.
Okay, take a look. If you still got any doubts about that part, you can let me know again. So I just don't need to repeat what's really already said in the lecture.
All right.
Okay, good.
Hi, Professor. I also have a question about the same chunk of code.
Sure, go ahead, please.
Can you change your screen back to that?
Yeah, over here, right?
Yeah, I was wondering why for the parameter you took the parent object instead of point v2 directly, since we're comparing the type anyways.
Can you say that again? So which line are you have you got doubts about? Which line?
Where you just circled.
Over here?
The parameter, yeah.
Okay, what about it?
Why don't we take the type of point v2 directly?
Oh, you mean here, right?
Yeah.
Okay, good question. Good question. That's something I didn't quite mention, but it's a good question. Okay, the reason is we want to make caller of the equals method as free as possible, so we are not constraining them. Let me show you what I meant. Okay, so for example, over here, let's say if we only define, let's see over here. So let's say public and then boolean equals. Okay, let's say we got only point v2, let's say. And then we have, let's say, other over here. So it's not a general object anymore. So I think over here, you can simply say return. So now the static type for other is simply just point v2. So you can definitely say this dot x equals other dot x. And also this dot y equals other dot y. Okay. This is definitely going to work. However, other scenarios wouldn't work. Let me tell you what scenarios. For example, let's say this. Let's say if I have, let me see what I can make over here. Let's say if I got objects over here, let's say this is a little bit more advanced, but let me try to explain maybe in a shorter way. Okay. Let me just write down some principle over here. Okay. The default version of equals method that is something we discussed. So it's like a public and then boolean and then equals. And that one there only got one type, which is what we saw in the lecture, which will be just be objects over here and then obj. And as we said, the default definition will just be return this equals other. Okay, that's what we have over here. Okay, good. So now, let's say if we actually go for this definition that you suggested, right? So this will be considered as an overloaded version of the equals method, meaning that these two versions will exist at the same time. Are you okay so far? That means both of these two will just be functioning, depending on which one we're going to call, which I will show to you. Are you okay so far about the two versions over here?
Yeah.
Okay, good. Okay, let me just say one more thing, and then I'll give you one example where it may not work. Both overloaded version exist. Okay, let's now take a look at one example here. Let's say if I got, let's say objects. Yeah, so this one here, I'll try to also give you a little bit intuition. That's also something we will see exactly why we can do such assignments when we talk about inheritance. Let's say objects, let's say P1 is, let's say point V2. New, of course. Point V2, let's say 3 and 4. And let's say we got another one. I'll explain that in a moment. Let's say P2. And then new, also point V2. And we also got 3 and 4. Okay, let's say that. The reason that we can do this, object and point V2, right? So That's also something I discussed briefly yesterday, but I'll reiterate that. Whatever declared type you use for a variable declaration, so it's called static type. So declared type, but the more precise term in this case will be called static type. Okay, and then we also got point v2 over here. So this is so-called dynamic type. Okay, public versus static versus dynamic. Okay, so now if we try the following, if we try this, p1 dot equals p2, you want to take a guess which version will be called? You can think about it. Let's say this is version number 1. This is version number 2. When we try to call p1 dot equals p2, version 1 or version 2?
Version 1.
You will hope, but it turns out it will be version 2, because since it's overloaded, point v2 over here versus objects, the way Java will decide which version of the overloaded version will be taken, it will look at what's the static type for the context objects. In this case, p1. You can see for p1, let me just highlight it for you to see. For p1, you can see the static type is actually objects, so that's why it's going to call to begin with. The version number 2 is invoke, because its static type happens to be objects. That's for resolving the overloaded method call. So that's some detail. That's a little bit tricky. And the consequence of this is, if I try p1 dot equals p2, then if we really invoke this particular version over here, apparently you can see this will be replaced by p1 and other. Oh, actually, I really meant to say obj. Okay, just let me fix that. Okay, let me put obj here. Obj over here, and that one there is actually p2, right? And apparently they are not the same objects, even though their contents are the same. But we have no choice, because given that this is the default version, we have no control over that. It just happened that this will be invoked when we try to resolve the overloading. Well, in that case, it's going to give you false. And false is simply not the right answer, because p1 and p2, not the right answer we are aiming for, because p1 and p2, they are different objects, even though their contents are the same. So that's why what we want to do is we want to choose the, we want to override this version only without creating an extra version. And in this version over here, the way we override it is to make sure when their dynamic types are different, we simply return false. And when their dynamic types are the same, we're going to cast and then to compare the attributes values accordingly. Does it make sense to you?
Yeah. Can you briefly explain what static type means? I'm not sure if you already gone over that already.
Sure. Static type, the definition is very straightforward in the following sense. Whenever you declare some object, okay, let me just do it again. Okay, let's say this. Let's say if I write a line like this, if I say objects over here, let's say obj is new. Let's say, you know what? Let me start with something you would know first, and then I'll do a little bit of variance over there. Let's say, let me just give you one example. Let's say products, right? I think that's one of the, product should be okay. Let's say products. Let's say products, P is assigned to new products. And of course, we got some serial number, different attribute values over here if you want to. Okay, so the way to identify the static type is simply look at whenever you're declaring this variable here, and the associated declared type is the static type. And the principle is it never changes. Never changed. And after the new keyword over here, this is called the dynamic type. And it may be changed for as many times as you like. For as many times as you like. The reason that we didn't have too much confusion up to this point is because every time when we actually try to do this and this, the static and dynamic types usually just match. But in general, they don't need to match. When they actually don't match, you will have to distinguish between them. And the way to do that is the declared type for the variable is static. And the one after the new keyword will be dynamic. Let me just give you one more example, okay, which I also used yesterday. So let's say I have, let's say here, let's say objects over here. Let's say, again, obj is, let's say, new products. So in this case, object will be the static type. Product will be the dynamic type. So now how can we change the dynamic type? If you want to do it, you just do some variable reassignments. So I can say, for example, obj following this line is simply new. I can put anything because object is a very special static type. You can allow any dynamic type to be compatible. But that's something we'll really specify precisely what I really meant by compatible. But for now, so I can say new, maybe account. Okay, so basically when we go from this line to this line over here, we are basically changing obj's dynamic type. At this point, it's actually products. Change that from product to account. Yeah, just a little bit more diagrammatically. So let's think about this is 1, this is 2. So when we do number 1, obj is pointing to this particular object over here, and the title of the box will be products. So this will be number 1. And when we do number 2, rather than pointing to over here, it is now going to point to just another object over here. Let me just make a little bit more space here. And then now it is going to point to some account objects. Right? So that's the new dynamic type. And how can you check for the dynamic type in this case? So let's say after 1, if you try here, obj.getClass. That one is going to return back to you the product class. On the other hand, if you try here, obj.getClass, that one is going to give you the current dynamic type, which has been changed to account. Yeah, so is that clear to you about static versus dynamic?
Yeah, so does that mean that all primitive types are static?
So static versus dynamic types are only for reference type. But for primitive type, for example, let's say if you do things like, let's just see one example here. If you do, for example, integer I is assigned to 3 over here. So number 1, so you wouldn't, this integer over here, you will only say it's declared type. But you wouldn't really say it's, you wouldn't want, you would not want to call them static. Because usually whenever you talk about static, you should really have some relative, like the opposite side, which is about the dynamic type. But in the case of the primitive value, we don't really create any objects in the memory. It's only a single value. So that's why you only say that's declared type without saying it's a static, which will imply there should be some dynamic type, in which case, no, there is no dynamic type for primitive value. Make sense?
That makes sense. Thank you.
Very good. But I would say get some intuition now just about static type for reference variable will always stay the same. And dynamic type might change as we wish. But that's something we'll see once we go on to next 2 weeks lecture. Okay, good. All right, so let me see. John, go ahead.
Yeah, Prof, I had a question. if you could go back to the previous slide in the iPad notes.
This one?
Yeah.
Go
so
ahead.
For that second, the overloaded default version of the default version of the equals method when we include it in our code. Yeah. So if we had when we do it in our code, we had the class point v2, and then we would pass into that equals method a point v2 object, and we say that when we passed it in there, we lose all the attributes that it had because now its static type is object.
That's correct. That's correct. So John, you know what? Let me go a little bit further. That's a very good question. Very good question. But that one there, I'll try to explain a little bit briefly. But I think once we go to inheritance lecture again, we're going to see the full picture. But you're quite right. Let me show also to your fellow student what you just said. It's a very good observation. Let's say this. Let's say let me just try to draw the context over here. Let's say we got a class point v2, right? Let me be consistent with what you learned in the lecture. So let's say here we are trying to override. So we say public and also boolean equals, and then let's say we say objects over here, obj, okay? And then the rest is about what we just discussed in the class, right? Okay, let me just put this definition aside, and then let me just go back to John's question, okay? So let's say this, let's say in some tester code, let's say we have, let's say point v2. Let's say p1 is assigned to new point v2. Let's say 3 and 4 over here. And let's say we got point v2. Let's say p2, which would be, let's say, new. Let me give a maybe different content just for, doesn't matter. Okay, let me say 6 and 8. Okay, and let's say if I say now p1 dot equals p2. Okay, before I do anything, let's try to visualize exactly what's happening over here. So the visualization will be, let me see. So we got p1 pointing to some point v2 objects over here, right? Let's just draw that. So point v2. And for x and y, we simply got 3 and 4, right? 3 and 4. And we also got p2, also pointing to some point objects over here, point v2. And for x and y, we actually got 6 and 8. Good. Okay, good. Now, I think John's question was mainly focusing on p2 over here. Let's understand one thing here. So here, just for p2 alone, if I try to say p2.x, p2.y, both of them will just compile, right? They will compile. That's not the issue. The reason is p2 was declared to be of static type point v2, which will allow p2 to refer to any attributes that's kind of specific to point v2, right? Remember, we actually declare x and y in point v2. So that one should be okay. But now, why would we actually lose? Why would we actually lose the ability to actually call x and y once we go to the method call? So now I want you to recall what you learned this week about call by value. If you haven't started the lecture for this week, for week number 6, you may want to start it very soon, because I think call by value will definitely help you understand the issue a little bit better. Let me just mention that, okay? The principle of call by value really allows you to see what's really happening behind the scene. That's automatic. So here you can see P2 over here, and then we are calling this method equals, and this is the parameter over here, right? Let me just write it down, and then I will show you exactly what's going to happen. So P2 over here is the arguments, and obj over here is the parameter. And as you go through the lecture, you will see how we distinguish between them, right? I'll let you read it, study the definition over there. And whenever we're trying to make a method call, what's going to happen is there's something called call by value over here, right? This is the method call. This is the definition of the method being called, or we say caller and also callee, right? That's what we learned earlier. So the principle about call by value over here is we're going to do some variable assignments. Namely, we're going to say the obj parameter is going to be assigned to P2. Okay, so what's going to happen is like this. So we're going to have something like over here. Let's say use green. So we're going to say obj is assigned to P2. By executing this assignment over here, we're saying that obj over here is pointing to the same object. So they're aliases, but there's a fundamental difference over here. You want to know that for P2, it was declared to be of static type point v2. The static type is point v2. What about parameter obj? It was declared as static type objects. Static type is different. So this is something you will have to be very familiar with and also feel comfortable with once we get to the inheritance lecture. So now I can think about it's more like a warm-up, right? Even though these two pointers are really pointing to the same objects, however, their static type is actually different just because of the call by value. We're using P2 over here and we pass that as argument into a method where the parameter was declared as very accommodating, which is the object one. So the catch would be we will lose about the ability to call x and y on obj. Okay, so now there's something we can also say obj over here, obj.x and also obj.y. If you try to make such method call, it will not pass. It will not compile. So now you can see does not compile, but it will compile. So John, does that answer your question?
Yes, but then when we can't, right now, what do we know the reference type of obj?
Mm-hmm. So that's why. So you can see obj was declared to be of static type objects, and we know that object does not allow any well, more precise, object does not declare the x and y attributes that are actually specific to point v2. So that's why without a cast, you just cannot proceed with to say something like a return over here, like a return this dot x and the other dot x, right? Because the static type somehow you want to cast to make sure you can do that.
So when we cast, but we don't change the static type when we cast. So
yeah, in some way. Okay, let's see this. Okay, let me just use the same diagram over here. Let's say at some point in the code. Okay, let's say at some point of the code. Okay, what we will say is, this is very good. Let me just continue to complete the picture. At some point, we will say point v2, knowing that they get class, are actually the same. Let's say point v2, we say other is assigned to the cast version. Say point v2 and then obj. So now what's going to happen is the cast is actually not going to create any new objects. Instead, it's simply going to create an alias. It's going to create an alias. Let me write it down over here. It is going to create an alias of obj. That's the variable being cast. But with the cast type. What's the cast type? It's point v2 over here. So the cast type being the alias new static type. So what's happening is what's going to happen is other is going to be the new alias we're creating. So that means other is going to point to wherever obj is pointing to. It's going to point to this object over here. However, its static type is going to be also the cast type, which is point v2. So now in this way, we will be able to say other.x and other.y. Whereas you cannot say obj.x and obj.y. You cannot do that. Does it clarify for you?
Yeah, and then we lose. Then are they still both like they're not? Are they both accessible, or do we lose that first obj? Because when we do
you can think about obj. The reason that we have to declare obj to be of type objects is actually for the reason I explained a little bit earlier to say, if you simply make this one just point v2, then there will be certain scenario that the equals method wouldn't work because you're too constraining about what can be passed over here. Okay, so given that we write objects over here, you're right. Because the call by value, we're going to say obj is assigned to p2, which is the arguments. In that case, obj is actually declared to be of static type objects. So we cannot write directly obj.x and obj.y. So that's why at the end, in the final stage, we have to cast that obj into point v2, which will effectively create an alias called other. And other is going to have the static type the same as the cast type. In that case, we can use other to say other.x and other.y.
Okay, so just a quick summary. When we did that object obj, our static type becomes object, but since our argument was of point v2, our reference type remains point v2, and then so in one of our if statements, when we compare classes, that's still true as long as we pass in a point v2, and that allows us then to check that the specific parts of that object as long as we then cast it into point v2, right?
John, can you say it again? Say a little bit more slowly so I can make sure I understand every word.
Yeah. So when we pass in the argument as object, our static type becomes object. Our reference type remains point v2. So then when we compare...
Okay, pause here. It's not exactly precise, John. Not exactly precise. So the call by value over here, I'm talking about, okay, so I say obj is assigned to p2, right? To be more precise, you can think about this part here is about decoration. So we're really saying objects over here, obj, is assigned to p2 over here. We are not modifying the static type of anything. We are not. What we're doing is, so p2 originally pointing to the point v2 objects over here, we are creating an alias obj over here. And obj is also pointing to the same objects. And then because obj was declared to be of type objects, so that alias has the static type objects. So what we have is p2 and obj, both of them point to the same objects. However, their static types were never modified. Whatever they are declared to be, like a point v2 versus object, they never changed. That's something I want to be precise.
I understand. So when we create that alias, since we're still pointing at that object,
so,
title point v2.
Yeah. So given that we can never change the static type of a variable once it is declared, especially since obj has already been declared as static type objects, we can never change it. What we can do is simply create just another alias, which will point to wherever obj is pointing to, and then the way to give a more specific static type for this new alias is by using a cast. That's what we're doing. But we're not modifying the static type for objects. We're never doing that.
I understand perfect.
Yeah, so John, it's a very good question here. I would say try to see as much as you can understand here. We'll definitely review this once we get to, there will be a part of the inheritance lecture where I will talk about more about the rationale of why we're doing cast. It has to do with some inheritance limitation of our computer, which I will address as well. Yeah, but for now, hopefully that's at least clear. Okay, John, any follow-up?
No, thank you.
Okay, very good, thank you. I can see Adnan, you got one question here, but just bear with me. I want to point out one correction, which I just said, just realized. Minor correction. Back to your earlier fellow student's question, I want to say this quickly. So you can see here, I said before, when we try to call p1.equals p2, where p1 and p2, they're of both type objects over here, right? I said that the reason that we're going to invoke the reason that we're going to invoke the default version of the equals method that's inherited from object class is because p1 over here is of type objects. I said it wrong. Okay, let me correct that. Sorry about that. Let me tell you what we should understand that. The rest is still correct. So the reason that we are actually going to call that version there is because, so let me just fix that quickly. The way to resolve overloaded methods execution is by looking at the arguments, right? Remember the very definition for overloading, right? Let me just remind you quickly. So when we talk about overloading, method overloading, method overloading, that simply means the parameters of the same method of the same name. Parameters of different types. So if you really want to resolve the execution of the correct version of the overloaded method, you have to look at what's the arguments at the runtime, right? So following the logic here, so the reason that we're going to execute the default version is because P2 over here. I think that's what I meant to say. I just realized I said it wrong. So P2 should be the reason that we actually executed the default version. Okay, let me just point there. So P2 over here will tell us that we should really execute this version number 2, which is default version. So P2, you can see the static type is simply just objects over here. Right. So let me erase that. So this one should not be highlighted. Instead, this one should be highlighted, object over here. Okay, so because P2, the static type is simply objects. That tells us we should really execute this particular version where the static type over here will actually match. Okay. All right, so that's something I want to clarify very quickly. Okay. Adnan, question, please.
Hi, sir. I just joined, so please don't mind me if this question is already answered. Like, watch it if it is. So in part D of lecture 5,
okay,
5, I guess. You traced an example that I think the last part has to be something different. If you could please.
Yeah, let me just give me a moment. Let me bring up the lecture so you can tell me which one you're referring to. You said part D?
Yes, part D.
Okay, let me go there. Is it this example here?
Yes.
This one. Okay, which one? Which line are you talking about?
The last part.
Okay.
Case 2.
Yeah, sure. Let me copy this page over here so we can speak about it. Sure. Give me a moment. Okay. Okay, which line?
Okay. So in case 2, you're saying that if equals is explicitly overridden in expression 1, right?
Yeah.
So when some method is explicitly overwritten, it means that it's not the same as it was in the default one that's being inserted.
That's correct,
right?
That's correct. That's correct.
Then I guess when we say the first assert equal, P1 is P1 and P2, then it doesn't really mean that we are saying P1 is equal P2, because then it's not overwritten anymore. If you could just clear the answer.
Okay. Let's start from this one here. Okay. Let's say we say assert equals. First of all, whenever you say assert equals, you're really saying argument 1 dot equals argument 2. So this is really equivalent to say assert true. And then we say P1 dot equals P2. Okay, first of all, that's what we have. And then more to it. Now, for the equals method here, where the P2, you can see that one there. Let me say this. So we are assuming that we have the following structure. So we got the object class, and also we got extend, and also we got the point v2 class. Sorry, the first one is point v1, right? Okay, point v1, the first one. Okay, that's fine. Yeah. So in the case, for the object class, we actually got the equals method. Okay. And in the case of point v1, it does not explicitly override the equals method. That means this will be directly inherited to over here. So that will be the version. So that's why when you see p1 that equals p2, it would be as if you actually you call this version over here, and then that one there is like a this equals obj. So that's why this will just boil down into p1 equals p2. You will only.
Sir, sorry to cut you, sir, but you're saying that overwritten in expression 1, whatever is expression 1, we are overriding that. So
yeah. So
in this case, P1 is expression 1, so that means it's overwritten.
No, P1 is actually here, right? It's point V1. Remember in point V1 class, we did not have the overridden version of the equals method, only in point V2.
Yes, I remember that. I remember that.
Right.
Just still confused about maybe the way you say case 2, the way you have said case 2. You're saying it's overwritten in expression 1. And when we see the first assert equal,
no.
Yeah,
let me help you a little bit further. Let's say this. So let's read it together. If the equals method is explicitly overridden in expression 1's declare type, right? So now you can see expression 1. Expression 1 is actually P1 in this case, and P1's declare type is actually point V1. And we know that in point V1, the class, we did not actually explicitly overwrite the equals method that's inherited from the object class. So that's why it's still going to use the default version over here, which will only compare the addresses.
But then why do we say that it's explicitly overwritten? But we kind of say it there that now it wasn't overwritten, now we are overwriting it.
Oh, I see what you mean. The reason that I'm still showing, okay, yes, I think the reason I show V1 and V2 here is actually for comparison. To say that in the case of P1 being here, so that means we're still calling the equals method here because it's not explicitly overridden. In the case of P2 and P3, in the case of P3 over here, its declare type is actually V2.
Yes.
Where it is indeed overridden. So that's why in this case over here, it's going to call the equals method in that particular class. I just want to show you a comparison actually.
Okay.
Compare.
Okay,
Yeah. Maybe I guess maybe you thought since I talk about case number 2, so every one of them would just be case number 2. Maybe that's what you thought. Not really.
Yes,
I think
that's what I thought. Yes.
yeah. So I think that my intention really was for the first two, because their declare type is simply just V1, where the equals method was not overridden. So that's why the corresponding behavior would be just default equals. On the other hand, in contrast for P3 over here, the declare type is actually V2. So that's why it will call the overridden version. I just want the contrast between the two cases.
Okay, it makes sense now. Thank
Okay,
you so much.
Yeah, no problem. Yeah. Good. All right, guys. Any more questions? Oh, actually, we are done with actually quite a long story we have discussed. Okay, over here. But let me just do a quick recap about what we have seen so far, just to also remind you what you have to pay attention to, especially for your test and exam. I think that's important. Okay. I want to go back to your fellow students' original question, a good one, about why we wouldn't actually go for other and here just go for point V2, right? I kind of explain the reason quickly, and I would say you don't really have to worry about answering this kind of version of the equals method in the test or exam. If I do decide to test you about it, I'll tell you explicitly before the test. But I don't think that's going to be the case for written test 2. Okay, so you can always assume whenever we got this default version of the equals method from the object class, and whenever we want to overwrite the equals method, we will simply just go and declare the obj, the parameter, to be always objects. Right? Because whenever you declare something other than objects, you have to face another extra layer of complication, which is about, depending on the type of the arguments, you have to execute the right version for the overloaded method. I don't want you to deal with that extra complication. That'll be too tricky. Okay, we don't need to deal with that for this course. Number 1, and number 2, about the static type versus dynamic type. That's something like a static versus dynamic. So that's something we'll definitely go into complete details when we go to the inheritance lecture. Okay, so about how you can modify the dynamic type from one to another. That's something you can just have some intuition just for now. Okay, and then this is just this is a question that was raised by John, just about whenever we try to let's say P2 over here, the arguments which was declared as point V2, and we can actually call P2.x, P2.y. That one's no problem. But as soon as we try to pass this argument to the equals method, and according to call by value, which is what you have to go over for week number 6 lecture, and call by value is this first topic. Okay? You want to make sure you go over that. And because call by value, we are really creating an alias of P2. So P2 is pointing to this object over here. We are simply creating OBJ, which also point to the same objects. However, these two aliases are fundamentally different, even though they are pointing to the same objects. So how are they different? For P2, its static type is declared to be .v2. For OBJ, its static type was declared to be objects. So that means you cannot simply write obj.x, obj.y, because the static type objects does not declare those two attributes. You just cannot. And this is why at the final stage of your equals method, once you know this and also obj, dynamically are really pointing to obj and also this. They actually point to the same objects of the same dynamic type. In that case, you can do some cast. And the cast is really to create another alias for the same objects. And that alias is going to be of the right static type. So you can actually say other.x and other.y. Right? It's I think this slide is very important for you to see, because that one actually links about what we said about callback value in week number 6 lecture. Okay. All right. So very quick recap about what you should know. Okay. Okay. So that's about it. I went over the Google Doc questions, everything, and then do you guys have any follow up about the lecture material? John.
Yeah, just to clarify, so when we went back to this texting version, so does that mean whenever we cast any object we have, that creates another alias of it with the static type of the cast we put in there?
Correct. That's correct. That's exactly correct. Let me repeat what John just said. Whenever you're doing a cast, the cast itself does not create any objects, like create any new objects. Let's say this. OBJ over here is currently referring to this object over here. So when we try to cast it to point v2, we are not creating a new object. Again, we are not. What we're doing is we're creating a new alias called other. And other is just going to point to the same objects. And the cast type over here is going to become the new static type. Well, I shouldn't say new. It's simply just going to become the static type for this new alias over here. That's what we're doing. So John, does that make sense?
Yeah,
I hope.
Just one more point. So we said now point v2 is the static type, but we say point v2 other. So we're just giving the alias of object point v2 and we're putting it into an other.
Yeah, so other over here and obj, both of them are pointing to the same objects, right? But their static type is actually different. The static type for other corresponds to the cast type over here. The static type for obj still corresponds to how it is declared to be.
Okay.
Yeah, good. Yeah, don't worry. We'll definitely review this. I'm gonna cover this again in the inheritance lecture. So you definitely get a chance to reinforce. Adnan, do you have more questions there? I can see your hand is still up.
Oh, sorry, sir. I forgot to.
Oh, okay. No worries. No worries. Okay. Well, guys, as I said, I will the practice question for you for written test number 2 will only be released hopefully by the end of the coming Tuesday. Before that, you definitely want to catch up with all the lectures for the listed topics in the guide, right? And then I'll give you the practice question on Tuesday, and then you will definitely got 1 or 2 days to actually try. And then hopefully that will be you can also ask me questions during the Q&A next week. Okay. All right, any more questions you want to ask me about equals or other things? Anything else? I'll pause for one more moment to see if you guys got any more questions. But I would say that's something I'm going to also mention to your fellow students. I think, as I said, starting from week number 7, the coming week, we will talk about inheritance. We're going to talk about inheritance. We're going to talk about abstract class interface and generics. So for the coming 2 to 3 weeks of lecture is extremely crucial. So I'll really urge you not to procrastinate or delay the watching of the lecture too much. You definitely want to make sure you learn these coming 3 weeks or 4 weeks of lecture very carefully. I think they are very interesting ideas, but they are challenging. Okay, you don't want to stay behind. Okay. Let me see. Okay, so one of your fellow students, there might be a spelling mistake in toggle measurement. can you either send me an email about what you think the typo is, or you can maybe come to my office hour today, tell me what the typo is. If that's really a typo, maybe it's better to let your fellow student know as well. Can you drop by my office hour? Or send me an email to let me know what it is. Okay, good. Okay. Yeah, so we can benefit not just you, but also, you know, everyone in the class. Okay. All right, guys, thank you so much for coming. And then, okay, that's about it for this week for the Q&A. But as usual, drop me an email or drop me my office hour if you got any doubts. And I will see you next week to talk about aggregation composition. All right? All right, guys, you take care. Bye-bye.